Okay, so for this video, we're going to walk through how to do a Pearson correlation with some of the data we've gotten in class. And we're going to walk through how to analyze that, how to do the correlation, and then to see if that is statistically significant. Now, for this data, we're going to use Microsoft Excel. It's not the only software you could use. There is other statistical software out there. Excel, for something like this, I think is pretty easy to use, and so we'll use Excel. So one of the things you'll need to do beforehand, if you haven't already done it, is to install what is called the Data Analysis Toolpak. So the way you'll know if you have it is if you go into Excel and you go into Data, this link right there, over on the side, there should be a little tab called Data Analysis. If you don't have that installed, before we do anything, you'll need to install that. And the way we do that, if you go into File, and again, I'm assuming you're using Office on a PC, Office 365. If you're using a Mac, there's other ways to install this. So you can look on YouTube for that. I know most of you will be using a PC, at least for classwork. So you go to Info and go down to Options here on the side. In Options, there's a lot of Excel options here. One of those is Add-ins. And when you click on add-ins, a lot of different add-ins will come in. All the way in the bottom, and you can see all the add-ins that are available to you. They may look a little different on your computer. But one of the add-ins that comes with pretty much all the recent versions of Microsoft Office is what is called Analysis Toolpak. And so if you go down on the screen on the bottom where it says Manage Excel Add-ins, we're going to just hit Go. And here a new window is going to come up. Now you'll notice I already have this installed. So if you just click on Analysis Toolpak, so mine are clicked on already, I hit OK, and that is going to install them. Now when you go up to your Data tab, it should have Data Analysis there for you. So assuming you have that installed, if you don't have it installed, pause and install it, and then we'll continue. Okay, so you have Data Analysis installed, so I'm going to click on Data Analysis, and there's a lot of statistical options here for you. We may do some of these in other assignments in class, but for this one, we're looking to do what's called a correlation. And actually, it's a Pearson correlation, what we'll be doing. So I'm going to hit Correlation, and then a window is going to pop up asking me what data it wants me to correlate. So if you notice my Excel document here, I have some sample data. Made this up, so this isn't anything real per se, although the data is pretty accurate to what you would normally see for height, weight, BMI, and percent body fat. And so I've lined these up in columns. Each column has a header or a title, subject, height in centimeters, weight in kilograms, BMI, and then percent body fat using the bod pod, and percent body fat using our bioelectrical impedance meter. And then for each subject, it has their data. For subject 1, that's going to be in this row right there. Subject 2 is right there, so on and so forth. Okay. So the way to analyze this on our correlation is this asking us for the input range. So it wants to know, what data do you want to correlate? Now, I can do this column by column, and I could pick weight versus percent body fat or BMI versus something else. I'm actually going to correlate them all at one time. And so I'm just going to highlight the data I want to correlate. So I'm just going to pick these 5 columns right here. I don't really care about subject number because that's just telling me what number of subjects they are. That doesn't correlate to anything. So I've highlighted the height, the weight, the BMI, the percent body fat by bod pod, and percent body fat with BIA. So it now asks, well, how is your data grouped? Well, my data is grouped by columns. All the data are in precise columns. And it's asking me, are there labels in your first row? Well, there are. I used labels. So I'm going to click yes, click that checkbox. And then the last thing it wants to know is, okay, so where do you want this correlation done? Well, I like putting things in a new sheet in Excel. You don't have to do that. You can put it in an entirely new file with new workbook. You can put it on this page and output range, whatever you like. I'm going to use new worksheet, and I'm going to hit OK. And then this new sheet pops up, and I'm going to make these columns just a little bit wider so we can take a look at our data. Okay. So what it has done, it has literally correlated every value with every other value in here. And so correlation is always going to give you a value somewhere between -1 to +1. If a correlation is a +1, that means it is a perfect correlation. Now, the only way that's really possible is if your data are identical. And not surprisingly, all the ones here is when I compared height versus height. Well, of course, the correlation is 1 because it's the same data. So all those we're going to ignore. -1 would be a perfectly inverse correlation. In other words, as one variable went up, another variable would go down. We are always going to have numbers in between. And so as you look at some of these correlations, they all are somewhere between -1 and 1. So right here, height and weight, that is a 0.73 correlation. That's a pretty strong correlation. That's not a shock. The taller you are, the more you weigh. It just is not surprising. Some other ones, percent body fat is slightly negative correlated with height. That's probably just by chance. And so we can look at all these correlations, and generally stronger correlations are going to be above 0.5, 0.6, or -0.5, -0.6. And so the only ones we really see here are height versus weight, which kind of makes sense. Weight versus BMI. So in other words, how much you weigh is pretty well correlated with your BMI, not surprising. And percent body fat with bod pod and percent body fat with BIA. Now, that's not surprising. The correlation is 0.8. We would want them to be very, very, very well correlated. But it's not a perfect correlation. Well, how perfect is it? Well, one of the things we can do is to check how strong this is to see if it's actually statistically significant. Now, the way we do this, there's a few ways to do it. I'm going to show you the easier way. If you go online, and I have a web page already pulled up, I'll have the link on Canvas for you. This is a table that shows you, depending on the number of correlations you've done and your alpha value, which we're going to use as 0.05. In other words, how strong do you want to be, how confident do you want to be that this data is significant? It'll actually tell us how strong of a correlation you need for it to be statistically significant. So we're going to use 0.05. That's kind of a standard interval we use. And we had 10 subjects. So we're actually going to do degrees of freedom. We're going to do 10 minus 2 is 8. So our n is actually 8. And so if you look across, we need a correlation of 0.632. Anything above 0.632 will be statistically significant. Okay, well, let's look at our data. 0.632. Well, if you look at our data, there's only a couple correlations that are that significant. 0.735, that one, 0.86, and 0.804. In fact, we will highlight those, and just to kind of make those point out. So those ones are statistically significant. In other words, those correlations are very significant. There are other things here, but those aren't so strongly correlated as they're significant. So that's how we do a Pearson correlation. That is how we test for significance. If you have any questions, feel free to email me, and good luck with your assignment.